Hi, everyone. This last part in 8.4 is optional, but you're going to see this a lot in Math 252, calculus with really analytic geometry, the 3, where you deal with three-dimensional things. Now, we talked about the dot product of two vectors in R whatever, R2, R3, R4, based on the number of components you have. But in 3 space, there's also a cross product or vector product. So if you have two vectors A and B, right? So this vector A, number, comma, number, comma, number, vector B, number, comma, number, comma, number. A cross B can be constructed as follows. So you have these bars for determinant. It's really called a pseudo-determinant because you're not supposed to put vectors in here, but we have vectors in here. I is 1, 0, 0. I mentioned this before with vectors. J is 0, 1, 0. And K is 0, 0, 1. So in 3 space, we often draw I like that, J like that, and K like that. We often orient the coordinate axes like so with the corresponding vectors. And then you put vector A in here, the components. You put the components of vector B down here. And then you basically work out determinants the way you would normally do by Sarris's rule or maybe cofactor expansion, except you're dealing with these vectors in here, which is kind of weird. But they go along for the ride, right? And the idea is that, well, let's say vector A is here, and vector B is here. Then A cross B might be like this vector here. The cross product vector might be like this. It's orthogonal or perpendicular to both vectors here. And it's very useful because if you consider the equation of a plane, so here's a plane. Well, if you know a point in the plane, and if you know two vectors, quote unquote, in the plane, okay, then you get an equation for the plane. From these two vectors, you get a cross product. And it's kind of like the term joystick has been used, like the old joysticks from video games, where, or like a controller, where you have your point, and then this is like a, well, it's like a gear shift almost, or a joystick in the old Atari consoles, where you can kind of move this thing around. Okay, but the idea is that you get the equation of a plane. So you use cross products a lot in Math 252 because you often need these perpendicular vectors. They're called normal vectors. We use normal a lot. That's a normal vector to the plane. Now you could have taken the vector B cross A, which means you switch these rows, and actually that would be in the opposite direction. B cross A would be in the opposite direction, same length, but point in the opposite direction. The cross product is anti-commutative. B cross A is the opposite of A cross B. So not on the test, but you're going to see this a lot in Calc 3. And also I want to show you another product, another way to multiply vectors aside from the dot product. Okay.